Wherever the gold is present, you will find the glitter near that particular room. This is a knowledge what we are providing to the agent. For each action, he'll be reducing with the value -1 and -10 for using the arrow to kill the vampires. This proposition logic have a very limited expressive power. Hello everyone, welcome to one more session on artificial intelligence and application for 6th semester B.Ca student, as we are continuing the discussion on knowledge representation in unit 3. Myself Indu J, Faculty of Computer Science Department, Vidhyaashram First Aid College, the Temple of Excellence, MYSURU. We have discussed already what is knowledge base, how do we represent the knowledge, what is knowledge base agent. Many things we have discussed in the previous session. In today's session, we'll discuss particularly about one problem called as vampus problem, how this vampus problem can be solved using a knowledge representation or the knowledge base. Or we can say solving the vampus word problem using a artificial intelligence. So let us say what is vampus word problem. So what exactly in the vampus word is there? It's a simple word example to illustrate the worth of the knowledge based agent to represent the knowledge representation. Why we are solving this problem? Just to illustrate, we can solve these type of problems using the artificial intelligence with the help of the knowledge representation. What is the problem? Problem is that there is a cave which has a 4x4 room. 4x4 rooms means you will be having 4x4 grid here like this. Okay. So this will be the grid, 4x4 rooms connected with passageway. We have a way to go to one room to the other room. We have a connected passageway. We have a knowledge base agent who will go forward to this word. This is the environment what we are providing. In this environment, who is going to work? Knowledge base agent is going to work. So what are the criterias? The cave has a rooms with the beast, which is called as vampires. What we have? We have a vampires. Vampires is some type of virus, you can say, or some type of beast, as they have mentioned. You can say it has a beast in the particular room. We don't know which room the beast is, who eats anyone who enter into the particular room. Out of this 4x4, out of this 16 room, we don't know where the vampire is. So whoever entered to that particular room, he will eat that. The vampires can be shot by the agent. Who is going to shoot the vampires? Vampires is going to shoot by the agent, but the agent has only the single arrow. He has only one chance to kill the vampires. So in that, what we have to do? There is exactly what we have to do? There is some pits in the room which are bottomless. There are some pits in the room which are bottomless. If the agent falls in the pit, he'll be in the pit for forever. And one room is there with the possibility finding the heap of gold. Why the knowledge base agent has to travel through those rooms? Because he has to find the heap of gold. So that the agent goal is to find the gold and climb back from the cave without eaten by the vampires and without falling into the pit. This is the problem. Hope you understood. We have a 4x4 grid. Somewhere vampires is there, somewhere gold is there, and some rooms will be having the pits. Agent has to move across to find the gold. What is the goal of the agent? To get the gold without getting eaten by the vampires or without falling into the pit. This is a simple vampires word problem. Let us see the diagrammatic representation. This is 4x4 grid, right? 4x4 grid. Here somewhere vampires is there. Okay, currently agent is in the room 1,1. Agent in the room 1,1, which is a safe room for the agent. Wherever there is a pet, there the breeze smell comes. the pits, wherever there is a pit, nearby rooms have the breeze smell. Wherever the vampires is there, the adjacent cells will be having the stench smell. And wherever the gold is there, you will be having the glitters. You will be having the glitters of the gold to identify in which cell we have a gold. This is a vampus word problem. Here we have a pit, adjacent cell to the pit will have a breeze. What is the knowledge that we are providing to the agent is that the same. We are giving the knowledge to the agent saying that wherever there is a pit, the adjacent cells or adjacent rooms will be having the breeze smell, and wherever there is a vampus, the adjacent rooms will be having the stench smell, and wherever the gold is present, you will find the glitter near that particular room. This is a knowledge what we are providing to the agent. Using this knowledge, agent has to reach to the gold without eaten by the vampus and without falling into the pit. That is a goal, or that may be the solution for this vampus word problem. So how to find the solution for vampus word corruption? That is what the knowledge what we are providing, or the condition what we are providing. There are so many components which can help the agent to navigate the cave. The components are given follows. The room adjacent to the vampus is smelly and have a stench smell. Adjacent rooms will be have the stench smell. The adjacent rooms to the pit have the breeze smell, so that agent can understand we have a he has a pit nearby. So when there is a glitter near the room, that means room has a gold, right? And the vampires can be killed by the agent. Okay, agent facing to it. Once he goes near to the vampires, agent have a one chance to kill the vampires. But when vampires is killed by the agent, he will emit the horrible scream. Okay, horrible scream heard anywhere in the cave, anywhere in the 4x4 grid. So this is a condition or the knowledge what we are giving to the agent. How this environment can be measured using the piece measurement. So environment can be described using the piece description of the vampus word. What is a piece description? P stands for performance, and E stands for environment, A stands for actuators, A stands for actuators, and S stands for sensors. So what are these that the agent have? What is a performance measure agent should get? Agent should get 1000 reward points when he get the gold. That is a award. That is a performance measurement award what he is getting. If we eaten by the vampires or fallen into the pits, that will be the minus 1000 points he'll be getting. And for each action, he'll be reducing with the value -1 and -10 for using the arrow to kill the vampires. The game ends either the agent dies or come out of the room. This is a performance measure what we have for that particular environment. Now coming into what is the environment we are providing to the agent. First, it will be having 4x4 grid or the cave grid of the room will be having. Then agent initially in the room 101, which is a safe room for the agent. And we have to find the location of the vampires and the gold. For choosing randomly expected the first square, because first square is already safe for the agent. He has to find the where exactly vampires located and where exactly the gold is there, right? So each square of the cave can be the pit. How far the pit in each room is there? At the point 2 expected values, the pits will be there in the particular grid or in the rooms. So this is what the environment on which the agent is working on. Coming to the actuators. Actuators is nothing but the action what the agent can take, right? He can move up, he can move right, he can move left, he can move down. So these are all the actuators. Turn, left turn, right turn, move forward, grabbing the gold, and then release. We can release the arrow, we can shoot the arrow. So these are all the actuators that the action agent can take. So depending on the sensors. What are the sensors agent can have? He can sense the smell, right? So smell of breeze, smell of stench, and he can see the glitter near the room. That is what they are presenting. Sensor agent can perceive the stench smell if he is in the room adjacent to the vampires, or agent can perceive the breeze smell if he is in the room adjacent to the pit. The agent can perceive the glitter if he nearby to the room which is gold is available. The agent can perceive the bump if he hit on the wall of the room. That is one more sense what he can have, that is bumping. When the vampire is shot, he can emit the screaming, like horrible scream, which can be perceived anywhere in that particular 4x4 room. These percepts can be represented in 5 elements as we have listed, in which we have a different indicators for each sensors. So what are the sensors we have? We have 5 sensors: stench, breeze, glitter, and then bump to the room, and then screaming sound. These are all the sensors using which the agent can try to reach the gold room. So exploring vampires word problem, how we can reach. Now we have given the problem, what is the environment, what should be the outcome of then, what all the action he can take. Now let us see how he can reach to the particular position where gold is present. So in the first step, agent, where the agent is in 1x1. This A represent agent is in which room, and if we are saying okay, that means that particular state or that particular room is safe for the agent. And if we are representing with a V means already agent visited the particular cell or the room. Then if there is a S, stench, that gives the stench smell. If there is a P, he can assume that there is a pit nearby. And if there is a glitter, he can see that he is near to the room where the gold present. So what exactly he'll do in the first step? Initially the agent is in the first room, that is 1x1 room on the square, and already knows that there is a room safe for the agent. So here we don't have any stench smell, no glitter, no breeze smell. So agent is in safe place. After this, in the second step, what he has to check? He has to either can move to the up or he can move to the second cell. That is, he can go to 1,2 or he can go to 2,1. If we go to 2,1, here we have a pit, right? Here we have a pit. So he can smell breeze here. He can smell breeze. That is represented here. Agent is in currently 2,1. He can smell breeze. That means agent can perceive there is a pit near to that particular room, adjacent room, right? So in the second step, now the agent needs to move forward so that he can either choose 1,2 or he can choose 2,1. He can go to 1,2 or 2,1. Room 2,1, at this agent perceives some breeze smell. That means pit is around the nearby the room. The agent will go back to the 1,1 because nearby pit is there. So agent will go back to the 1,1 and it will be marked as visited because agent had moved to 2,1 and came back to 1,1. Then after that he'll move to the 1,2. Then visited by the agent. So we will use the symbol V to represent the visited square. At the third step, what? He'll visit 1,2. 2. Agent is now in the 1, 2, which is okay state, In the room 1, 2, agent perceives the stench smell because we have a vampus here. Whenever the vampus is there, adjacent cells will be having the stench smell. So what he'll do? Nearby vampus, he assumes that there is a vampus in nearby cell. But the vampus cannot be in the room 1, 1, so he'll again come back to the 1, 1. And also not in 2, 2. Then he tries to visit one more cell nearby, that is 2, 2. The agent had decided any stench when he was at the 2, 1. Then what next step agent? But the vampus cannot be in the room 1, 1. So he'll go back to the room 2, 1. Therefore, the agent assumes that the vampus is in room 1, 3. Right? Vampus is in room 1, 3. And in the current state, there is a no breeze, which means in 2, 2, there is no pit also. He'll move to the cell 2, 2, assuming that there is a no stench smell and no breeze smell also. So he'll be safe here in the 2, 2. That is what represented here. So he'll be visiting 2, 2. There is no pit, no stench smell. So he'll be visiting 2, 2. After visiting 2, 2, again he has to check with the adjacent, whatever is there. Because 1, 2 is already visited, we are skipping that. We are checking with 3, 2 and 2, 3. When agent comes to 2, 3, since it is a pit, we have a breeze smell here. So he cannot, so come back to the 2, 2. And when he is in 2, 2, he can find some glitters. He can find some glitters nearby. So he assumes that the gold is there in 2, 3. At the room 2, 2, here no stench and no breeze present. So let's suppose the agent to decide to move on 2, 3. 2, 3. Here he visited 2, 2, no smell, no breeze. So it is already visited. When he visit to the 3, 2, he'll be having the breeze smell. That means the pit is nearby. So he'll visit to the 2, 2, assuming that there may be the gold. At the room 2, 3, agent perceives the glitters. He can see the glitters of the gold. So it should be grab the gold and climb out of the cave. So this is a solution what we are providing for the vampus world problem. So agent based propositional, how we can put in the same solution in the propositional logic, what we have discussed in the last class or last session. Whatever the solution we got for the vampus word problem, we are putting in the form of propositional logic. We also demonstrate how the agent may keep the track of the world without having written to the percept history for each inference. Finally, we demonstrate how the agent may develop, plan and guaranteed to meet the objective. What is the objective? To get the goal. Guaranteed to meet using the logical inferences. How we are achieving the logical inferences? First, that is using the propositional logic. Understanding the axonomy, we have provided some symbols here. This is, we have provided one symbols. Axonomy we have provided here. Okay, R1 means negation of S11. Negation of S11 means there is no stench smell in the room 1, 1. No vampus in the room 1, 1. No vampus in the room 1, 2 and no vampus in the room 2, 1. Similarly, in negation we are using for the axonomy R2. R2 represent what? We are searching with the stench smell in room 2, 1. There is a smell in the 2, stench smell in the room 2, 1? No, right? So there is no vampus in the adjacent cells also. That is no vampus in 1, 1, no vampus in 2, 1, no vampus in 2, 2 and no vampus in 3, 3. Again in axonomy 3, what we are searching? We are searching with the respect to the cell 1, 2. In 1, 2, do we have a stench smell? We are checking 1, 2. We don't have a stench smell, vampus in 1, 1. No vampus in 1, 2. No vampus in 2, 2 and no vampus in 1, 3. So this is the axonomy what they have provided. Applying the modulus prone with the S1, that is a no stench in 1, 1 with the R1. What is R1? This is the axonomy what we have provided for the R1. So R1 gives what? R1 is equal to negation of S11, which implies negation of vampus, negation of and negation of vampus and negation. This is the AND operation. AND operation. This is implies. We have discussed what this implies and the AND operation when we are discussed with the propositional logic and how does it works. So this particular total will be what? R1. This total will be R1. Have the applying the modulus prone problem to this S11. So these two will get cancelled. Yes, these two will get cancelled. What we have left with? W11, W12 and W21 we have left with. Similarly, the statement after applying the elimination rule, we are eliminating S11 with that S11. What we get? W11, W12 and W21 we get. Then what we have is a second problem. That second for R2. We are applying the modulus prone problem for the R2 statement. R2 statement gives what? S21. Yes, S21 implies W11, W21, W22 and W3. Here also we are applying the elimination rule. Once we are applying the elimination rule, we are eliminating the negation of S21. So what we have left with? We have left with W21, W22 and W23. So after eliminating that, we'll be finalizing or we'll be getting the values. After this, we have to apply the modulus prone problem for R4 also. We are applying the modulus prone problem to S21 and then R4. What is R4? We have S12 implies W13, W12, W22 and W2. So here we can get cancelled, that is a negation of W1. So these both will get cancelled. What I left with? I have left with W13, W12, W22 and W11 I have left with. After this, what we have to do? We have to apply the unit resolution on W13 because we know already W13 there is no vampus because no stench smell is there. So after applying the unit resolution formula to W13, this here we are using the OR operation. Okay. That is for elimination method we are using the OR operation. So W13, W12, W22. So we are applying for W11, W11 and W11 get cancelled. And then what we have left with? 13, 12 and 22. Right. After this again we have to apply the unit resolution formula on this particular negation of W22. With the W22 negation and W22 negation will get cancelled. What I have left with? I have left with W13 and W12. Next, for W13 and 12, we have to apply the unit resolution with respect to the negation of vampus 1, 2. So these two will be get cancelled. Then what I have left with? I have left with only one cell, that is 1, 3, and that proves that the vampus is present at the cell 1, 3. So this is how we are applying the propositional logic to the vampus world problem. Once agent got that knowledge vampus may be in the room number 1, 3, he moved carefully. He leave the adjacent rooms and he moves to the different rooms to get the gold. This is what we have in the vampus word problem and solution, and how to implement this vampus word solution using the propositional logic. Coming again back to this, what is the disadvantage what we have in propositional logic? The topic of propositional logic, we have seen that how many represent statements using propositional logic, but unfortunately in the propositional logic we can only represent the facts. We can only represent the facts which is either the true or false. Propositional logic is not sufficient to represent the complex statement. Here what we are checking? We are checking whether there is a vampus or not. Right, that is a true or false condition. So only we can represent such type of statement. It cannot be represented complex statement using the propositional logic. This propositional logic have a very limited expressive power. So these are all things what we have a drawbacks in the propositional logic. So this is all about the Wampus word problem. What is the outcome of Wampus word problem, how agent is given with the knowledge base about the problem, and how agent can solve that problem using the knowledge base provided by using the propositional logics. Thank you.